Find the limit as xy approaches 0, 0 of this multivariate function here. So the first thing you should do whenever you have a limit is actually plug in the numbers that the limit is approaching. So x here is approaching 0, and so is y. So if you plug in 0, you get 0 squared times 0 over 0 plus 0, and so that's 0 over 0, which is undefined. That usually does not work. If you play with this limit a little bit and try approaching 0, 0 from many different directions, you'll end up getting 0 every single time. But how would you show that the limit is actually equal to 0? We'll use polar coordinates to do that, and I'll explain why this works at the end. So we'll let x equal our cosine theta and y equal our sine theta. And notice that as x and y both approach 0, that we have r approaching 0 as well. So we can replace x and y approaching 0, 0 with r approaching 0, and then replace every copy of x with r cosine theta. So this will be r cosine theta squared, and then here we have r sine theta. Then in the denominator we have, let's see, x is r cosine theta, so this is r cosine theta squared, and then here we have r sine theta squared. We can clean this up. This is the limit as r approaches 0. Let's see, here we have r squared and r, so r cubed, cosine squared, theta, sine theta. And in the denominator, this is going to be r squared cosine squared, and this guy here is r squared sine squared. So we can pull out an r squared, skipping some steps here, cosine squared theta plus sine squared theta. Okay, it looks like we lose a copy of r in the numerator, right? So we're left with the limit as r approaches 0 of cosine squared theta sine theta. I might be a bit terse here and ignore the denominator. And the reason we can ignore the denominator is because this is a famous trig identity, right? This is equal to 1. And we're left with an r here. I almost forgot my little r. So this is what we're left with. And obviously if you plug in 0 here, you get 0. But is that the limit? Well, it is, but it requires some justification, or at least you should know why it exists. Remember, for this limit to exist, we have to be able to approach 0, 0 from any direction, right? From any direction, and we have to get the same result. So why is it true in this case? Well, we have to make sure that this limit exists independent of theta, right? So that's pretty easy to show. If you notice, this is greater than or equal to 0, a little bit terse here, and both sine and cosine are bounded by 1. In other words, the cosine of theta in absolute value is less than or equal to 1, and so is the sine of theta. So this is less than or equal to the absolute value of r times 1, which is the absolute value of r. And then via the squeeze theorem, as r approaches 0, this approaches 0, this approaches 0, so via squeeze, this guy approaches 0. So what's inside approaches 0 as well. So this limit exists, and it's independent of theta. It doesn't matter what theta is, this limit is going to be 0. So the limit is in fact 0. That was kind of rushed, but hopefully that made some sense.